Good afternoon, everyone, and welcome back. Good afternoon, all, and welcome back again for the second session, a technical session of 5G online FGP on technology management. And today's theme is IoT and Smart Devices. I would request Professor Ranjan Kumar Behra to continue with the next session. So, over to you.
Thank you very much. So, good afternoon, everyone. So, today morning we saw that what are the smart devices. Then we discussed the story of an IoT, that how it was very beautifully built one structure to another one, how the transmission, what are the challenges in each device level. We discussed in the morning session. Now we will discuss few implementation, that how we can implement those technology for our own benefit actually. So as a small model you try to develop, you can understand that what is that. For example, in the Apple this mobile, if you are sitting for 15 minutes, more than 15 minutes, it will tell you are sitting 15 minutes, stand up. So you stand up. That means most of the time you are seeing today, the smart device, they control us and we don't control them. For example, nowadays in the WhatsApp, as soon as the message, some sound come, so immediately people rush, oh, there is some message. So like that, we will implement few system here, which is very common to everyone. For example, simple power supply. For example, the dockyard. For example, you have a car parking system where from the door itself you will understand whether there is a parking space or not. So those simple system which is available today, so we can use the device to understand and to implement. But implementation needed, that you must be performing that one exactly how it is. You must go to the site and study that one, and then you think of the complete design of this. So today we will see few system design where you can appreciate that it can be implemented whether it's in a business, whether in your department, whether wherever you want, a marketplace, you have a smart system, you can design a market system, marketing system for your shop, anything you can do. So here we will discuss few nanogrid system which implemented and the cyber physical in grid infrastructure also another concept behind this. And today morning we saw the architecture of the IoT, then network layer, and then sensor layer. Okay. Now networking, there are many things that the device, routers, Wi-Fi, Zigbee, wireless vehicle network. So there are many things. And then infrastructure, what you are connecting. For example, there is a fire alarm in a building, and the fire alarm was connected with your system, and it is integrated as soon as the temperature goes from your normal temperature, it will give this siren, or if there is some kind of fire in the system, it will detect and it will give. So similarly, so many things you can see. And then application interface where it can, for example, your Ola. Ola is one of the application where it is a direct user interface. Where is the drive location also you can see in the Ola. That is one of the applications. That is why the complete device is based on the one is the management and then another one is your security and service organization. Okay. Now, if you see this IoT, today IoT service like Slider Electric, they provides the IoT solution for complete your hospital they can design actually. So I remember once I was in Snyder Electric Development Center. They manufacture there in near Nashville. Okay, it is between the Cookville and Nashville in Tennessee State. So I visited with one of his engineer where we implemented one project there. So as we were moving and their workshop, as we are moving forward, lights are turning on and then turning off automatically. When we move forward, lights are on. When the backside lights are turning off. So completely, very beautifully they control that one. And that type of device and these are the interactive this one. And there are many communication technology that is today morning we discussed already. And those who are communication people, they can go detail into this one. And as we have just given the names I have given, and because you don't know where it is used actually. So when you see that what is your area and what is your distance from your plant, how you want to control, so accordingly you will choose the communication protocols. Okay. So there are many technologies most important is this the enabling technology, wireless technology, where we can use. For example, Bluetooth and PAN, which is IEEE 802, the device. This communication device you can use if it is less than 10 meter. Like in your Bluetooth, you can go up to 100 meter. Okay, but that should be a receiver must have that much strength. Okay, and it should be also most of the time it should be straight line, and that is how Bluetooth device they work. And then there are land device, which is 150 meter, okay, in that distance, local area network. And then one, then man, they are according to 50 kilometer, and 150 kilometer is a wide area network. So this way, we can design, we can choose the communication, wireless communication protocol. And these devices, when we want to develop any kind of IoT based network, you must consider this communication as the main technology where it can interact with each object and with the user. There are many Bluetooth Zigbee based systems today available also in the market, and there are many way of connection. This is the PAN network. Okay, the this you can see that this all this Bluetooth, the Zigbee Bluetooth are connected here, and they interconnected, and where you can get all your data, and this is the vehicle to vehicle communication system. And there are tiny computers which is available. And one of the important thing is that energy harvesting charging protocol actually. So many people, they work on energy harvesting protocol. And how a small solar or some kind of energy harvester, they can connect it to your sensor node so that it will, the sensor node have sufficient power supply. For example, one sensor node may contain many sensors actually, and they are connected, and one typical power is around 10 milliwatt, 10 to 50 milliwatt of power, each sensor node they require. And that way, you can harvest that power nearby from the sound or some kind of vibration or from the light, or you must give from the battery. Now there's the supercapacitor also, they are connecting. And then we have a IoT, and then we have a cloud system where you can you can connect the system to there. So IoT has different names. Today, after industrial revolution, Industry 4.40, which is another concept of Industry 4.0, is a cyber physical system that you must connect everything with the internet. So that cyber physical system is one of the very important concept today. And in the cyber physical system, when one physical object is connection with other physical object, you can study many ways. For example, one of your friend come to your home and he told, my dear friend, today we have a very lot of corona patient. What we should do then? So instead of become fearful, you can tell your friend, no, we should protect ourselves from this one. Or you can become even fearful from your friend and tell, no, 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 don't say this one. Don't come to this house. You go away. So many varieties of conversation can be taken place. So similarly, the cyber physical system also. When you have a different object, for example, the object is, one is Ganga river is there, and you want to measure what is the impurities level at certain point. For example, 200 crores Rajiv Gandhi Ganga Clean Mission Project was awarded to IIT Kanpur. I remember that time I was a student. So they used to go to all the places in the Ganga River at least 4 kilometer. Each sample they collect and they measure what is the But I asked them, what you found out from your study? Many people say many things. Somebody told that at this point, at our Kanpur, Bithur, and there lot of impurities are there. And somebody told the pH value of this water is this much. And somebody told me the structure of water is so uniform. And another person told me that the Ganga water contains the friendly bacteria which automatically they purifies the water. Where you will not get other water. You bring from any corner of the India and test those water, you will not find a friendly bacteria. So, although the same sample, but many people have understood differently. And similarly, this physical object can be understood. So, one of the example here I have given that a energy saving potential, like we have a lighting, ventilator, cooling, and compressed air, and space heating, hot water, everything you can plan to control. And when you control this one, then sorry, okay. So there are many ways of understanding your concept. You can see that there are four window or four display. One is displaying that the dynamically change of your load. Second one is showing that how you can optimize to use what kind of equipment at right time. And third one shows the how much energy you could able to save. And fourth one shows that where the maximum energy usage. So when you see a simple analysis, this is called the data analytic. You analyze the data received from a plant. And when you receive the data and you interpret, for example, I am an expert in electrical, so I will give suggestion how to be design this electrical system. If somebody is very good in the civil engineering, he can tell you what are the structural limitation and what are the structural efficient energy building, how you can connect. So many ways people can analyze, and that is called the cyber physical technology. That we can everything can be connected. So, for example, this is a simple uh, village near IIT Patna, where we plan to network these villages at least for the local power supply need. So, in this system, here we have just- so we have this. There are Dilavarpur village, Jaunpur village, and okay. So this you can see here. This is the network, and in this network, you can see that there is a power grid which is available, and this will connect to through a solar panel, which is 1 megawatt in our IoT partner, and supplying the essential load to this village. And there are a few storage also, like battery storage. So there were many control system we used here, and to control the power very intelligently. So there are different structure. First thing is you understand what is the limitation of the power, then you operate that power for supplying to the load. This is the first layer. Then second layer you go, energy management. For example, low important loads, okay, if you are, there are priority load, and the priority loads, they must be supplied first. For example, academic in IIT Patna. Academic is the primary thing. So academic load must be given priority rather than all residential load. They can be supplied later time. So then after that, how you will predict this one actually? That is the prediction layer. And then when human machine interface, then you can decide that how you will connect this. So if you see the integrated machine learning, before going into the IoT application, we must learn how to how to understand the data. Most important is the data. You get the information from the sensor and you don't understand what is it. So then there is no importance at all, the data you collected. So that is why you need, first thing is the data is the money today. So in the village area, we collected all kinds of the energy supplied, and we collect all kind of events held in the Patna city as soon as, for example, Prime Minister visit to Patna. So completely, nearly 100 megawatt of the power is channelized from the village area to your event. And that you must take care of that also. And those data when come, and all the environmental, all the events they come, and you should use signal processing, how to process the signal, and normalize, and you remove the noise, and dynamic feature extraction agent, then machine learning, then you can understand what is the load requirement area-wise, what type of grid connection you require, where you will get uninterruptible power supply. Then what are the optimal load? Which load are primary? What are the secondary? What are the tertiary loads? And what are the possibility of the failure, prediction, or the warning? So for this based one, in IIT Patna, we built a storage system with a PV system, which is a 12 kilowatt. And this is a simple microgrid structure. You can see this is a complete control unit, and where your all kind of converter from DC to AC converter and connecting to the load is given. And if you see here, this is these are the different power supply to different villages, and these are the data which we collected for 1 year data. So we see that this is the averaging that. And this is the power monitoring of IIT Patna unit. And initially, we did a smart DC microgrid for one of the place in the Araria district, and it is the Chitragupta Nagar. Okay, in Araria, Chitragupta Nagar, ward number 14. For them, one of our students, he designed this DC nanogrid. So what is this we designed? We have a different unit. One is power sharing, then closed loop voltage control, then monitoring unit, home server, communication. So this, whatever we studied and that just a morning class, you get by using voltage sensor, current sensor, the data. And those data you connect to your gateway device, which is nothing but is our microcontroller and our Zigbee. Then you process that data and connect to the cloud. So because here our IIT Patna internet is available, we can easily connect to that one. And this is a solar and feeding to a local load because village they have only one bulb or one. So we don't go in detail to that one. So if you see in a house, you required 150 watt of the power. Okay, a typical house in a not a big bungalow, it is small house. What is average power? They get 150 watt. So total of 1006.5 watt hour of the power, and you have a solar, then a battery, then a fan, tube light, laptop, mobile charger, and TV. And this is, you can see that this is the load profile where which time you have a peak load, accordingly you need to design that. And these are the parameters, and you can see here now. This is the online monitoring unit where we have a sensors here, and these sensors are, these are the, you can see that this is the communication protocol which is connected here, and this complete unit is tested, and you can see here online monitoring system where you can see there are two ports are there where you by just clicking here you can actuate the device. So that I told you, this clicking is your command signal, and command signal when it goes to this sensor node, it will actuate the device. So this is what the complete unit was designed. You can see that the communication protocol is here. This is the communication, and this is the complete load which is tested in the laboratory. And you can see here, this is you can have a get your the gateway device, okay, and this is your communication center. So when you see here, you can see that there are four switches. One is solar, then battery, and then port 1 and port 2. So just you click on the solar will, it will just disconnect the solar at your power plant. And the battery also, by seeing the battery voltage, you can turn on or you can turn off this battery from sitting in. And this portal is an online portal, you can see here. And it is anybody can, you can access by using your mobile also. So this way, you need not to go to Araria to stay there. Just by sitting in IIT Patna, we could be able to get all the data, whatever in the Araria district, Chitragupta Nagar, whatever there was data, we used to get that one. So this is one of our student Rustam who designed. He is not here now. He is in South Korea. So this way, this complete unit is designed. Here you can see that, you can see what is the solar voltage, what is the battery voltage, what is the solar current, battery current, everything you can see in the monitor, that how much it this can, and you can see this right hand side, the state of the battery, okay? This is your battery, okay? So this is my battery, and what is the state of the battery? Also you can see this much charge remains in your battery. This is the online portal, and this is complete design here, where both the converting devices, all the amplifying devices, communicating device, and processing device completely together, and it is tested in the lab for, because you required a DC fan and two DC lights and a resistive load and a battery. This complete unit is designed, and you can see that this is, after this is cost is only 12,660 rupees, okay? The complete cost including the solar panel, okay? So that is total cost is 12,660 66 per one device. So anyway, these are the different results. So this is in the Chitragupta Nagar. You can see here, he is Mr. Saran. This is Mr. Saran who is sponsoring the project. He stays in Switzerland, but whenever he come to IIT Patna, and he always be enthusiastic to connect everything to them. And this is the Chitragupta Nagar. And then we saw that in Bihar, government, once they requested, especially the irrigation department, they requested to give us a solar trees to the village rural. Solar tree means the solar energy in a concentrated form of like a tree. You collect the energy from the solar panel and use it for the different purpose. Like here, there are a few town here, we have already supplied the solar tree. And this, how to monitor this one? Because nobody is interested to stay in those villages, you need to monitor from this place. So we made this smart solar tree. And one of the student, Vinit, he designed this solar tree. The most important thing that solar tree design is that we must take the shape of the solar tree, how it will be. And this solar tree we designed initially by using CAD/CAM, AutoCAD software. And this is the shape of the solar tree, which initially we studied both mechanical strength as well as its operation. And then this small unit we developed in the laboratory, where you can see that it is just a 50 watt, 10 watt each panel, 50 watt, and the battery of 48 ampere hour battery was connected, and this complete unit is designed in the laboratory initially. And then we designed a 200 watt solar tree, although the Binit is standing here and designing in the WhatsApp in Patna, but this unit becomes very heavy. And because of that one, it is our test model. And after designing this one, this solar tree, you can see here in this figure that there are a black box. And that from the black box, there is a wire coming to this LED light. And both the sensor, they actuated for the lighting. When the solar energy becomes zero, this light will turn on. So this way, this solar, there are many design principles. We are not interested into that one. We are interested in the how smart we make this device. And we have a PV module, then complete charger, then a battery connecting to this load. And this, if you see, this is the complete solar tree, which is designed. And now we want to make this one into a smart tree, so that all the data remotely you can control all the management system without the human intervention. And that is why this is, we designed the solar tree, which is 11 feet, and each module is 20 watts. So 10 modules around 200 watt, okay, like that. So this tree we designed, and each module we studied. And after that, you can see that when we put the sensor, for example, these LED lights, when you put a sensor, then you must understand that how it actuates when the light is zero or the solar energy is zero. As soon as sunset comes, so that time you will see that solar energy is zero, or solar rays, insolation are zero. So power output will be zero. That time it will turn on this light. So 75 ampere hour battery, because we can back up for at least 8 hours. So like that, we designed that sunlight, then solar, then MPPT maximum power, charger, then a battery, then street lights are connected to this one. So we have given to one of the village near Kanpa here, near Bihita, because in their Kanpa, there is a community center, and that community center is distance from the village. So they want a solar tree. So we have their Sarpanch requested, so we provided that one. And we gave because in that village, most of the time, there is no power actually, 4 or 5 hours they get. So cell phone charger, two cell phone charger in the solar tree, we connect so that anybody can come. They can connect to the solar tree and accordingly they can charge their mobile and LED lights. And these are the calculating these different powers are the thing which is not. So then this then two axis rotation and this total structure is shown here and this circuit diagram other than testing in the laboratory and this is the complete solar unit and when this you can see here when our student he designed this one and this is our solar tree. You can see that as soon as there is a sunset, just a sunset, this complete solar tree became activated. And this, our students, they sit in the night time, just below the solar tree. They connect their laptop, mobile charger, and they study also sometimes. They discuss this one. So this is the how this solar tree is designed. And then another student, he made the solar tree as a smart solar tree. So there are students, first thing in the solar tree, how to design this one. One is how to design the communication system. Second one, based on the Zigbee protocol, because they are very less cost. And one is a measurement unit, your temperature, light intensity, and both voltage and current sensors. And then transmission unit, which is received by a receiver. Okay, it may be your mobile or through Bluetooth, you can send the data or by some communication. Then demonstrating this complete unit. So the most important goal is that first, to understand the performance of the PV. Second one, power loss reduction. Okay, how to optimize the operation so that power loss can be minimized. Then evaluate the system and increase the overall system efficiency. So we have one is a voltage sensor as a sensor which measures the voltage. One is our current sensor which measures the current. And another one is ambient temperature. By knowing ambient temperature, you can understand what is the power output, watt per meter square in a solar system. Then light intensity, this sensor today morning I told you, according to light intensity, its resistance will change. And then we have a wireless sensor network. And there are many forms of wireless sensor network. They can be a star connector, a mesh connector, or cluster trees. And the proposed system consists of one transmitter, a receiver, and the data acquisition and Zigbee router. Data acquisition system means we get data from the environment, how you will save in the computer. So when you take data from external world and read in the computer, that is called the data acquisition, how we read from the external world. For example, I remember nowadays it is very easy to acquire any data and put into computer. But when we were doing MTech, that time to get one data into the computer, that time the PCs are 208, and you have to write a 100-line program to receive one data. So that is what here also, but nowadays it is very easy. And real-time clock also, and microcontroller and GPU. If you see the system architecture, like today morning, we discussed about this architecture only, that you have a sensor. Okay, so these are the sensors. From the sensor, all the data collected from the sensor come to your gateway device. And this is your gateway device. Now, gateway device needs to be sent to the cloud directly, or it can give to some kind of edge device. In this case, you have computational data, you have some kind of edge device like Zigbee, okay? And this transmit this data, this Zigbee data, okay, uh, to this trans receiver, and here they receive the data, okay? So this way, you can see that whatever structure we studied in our IoT, the same structure you can appreciate here, the same thing, only we did. And what is the difference is that here, all the components are known to you. There we studied just a general form, okay, that much. And then you can store the data in your personal computer or in the cloud. So hardware of the monitor unit are Arduino 2 numbers and Zigbee 2 number module, charger 1 module, because you need to know how much battery is there in the charger unit. If there is no sufficient charge, you need to charge it also. Then LDR module, then temperature sensor, current and voltage sensors. Okay, these are the sensors. And if you see the hardware diagram, all the sensors, this is your PV array, and this is our PV array, and this one is our voltage sensor. It will measure the voltage. And then there is a current sensor. Always current is connected in series. And then this is a charger connected to battery also here, and microcontroller. All these processors are there, and this is how the hardware unit. And software work, they develop a beautiful software which will interface with your computer. And this is the flow chart. I'm not going in detail of this flow chart because this flow chart will give you the insight how the programming or how the apps are developed, okay, for this system. And if you see here, this is the complete solar tree. And if you see here, this is our place where we charge. Okay. This our charger is connected here, and inside I have given because if there is a rainfall, some water may leak or may touch that, it may short circuit. So that is why inside this hole is given. Inside this there are batteries. Inside this box there are batteries, the charger unit, the connector, all things are there inside. And the IoT device is at this top one, this one. And this box is situated here, and you can put it here because whenever you are not getting any data, this is very sophisticated equipment. So it may fail sometime. So that is why we put on the external. And this is the gate where you can close this gate and it will be closed here. So this way, the complete unit, you can get this data, and you can see that here it is the LED lights, PV modules, LDR modules, okay? These are the LDR module where you can see the temperature. What is the temperature? Okay. LM35 also the voltage regulator, and which is completely computed by these devices and gives the output signals. Okay. Now, if you see here, you can see that this temperature, whatever temperature is that time, you can receive in your mobile. And this is what your light intensity, and this is your voltage and the temperature. On online data, you can get by sitting anywhere in your office, you can get it. And you can get by using mobile app also, we can easily you can get this data. So by from here, you can analyze the data and then predict what is the next step or how to manage the battery, how to manage the source management, how the load can be managed. In this way, it is very beautifully designed for one of the small application in the power supply. There are many references. And then this is a smart powered home. And this for this we got the best project award by the DST. That this smart home you can see here. This is the smart home as a model actually. It is not actually smart home, but it is a model of a smart home our student developed. And the living room you can see you have a sofa and everything is there. And there is a corridor here where the people travels, okay? Whenever there is a corridor here, you can see here. This is your corridor where you enter here. This is your gate. As soon as you enter, you have a sensor here that will detect that somebody has entered here. And as soon as it detects, it will turn on this light. As soon as it turn on this light, if their room temperature is very high or more than 26 degrees, then it will ask this fan. This fan represents the air conditioning in the room and to turn on this fan. And after this turning on this fan, then if you are going to kitchen area, this is the cooking area. In the cooking area, first it will show you a turn on the light. Second, it will go here to this kitchen, and in the kitchen, whether there is a gas leakage or not. If there is a gas leakage, then it will turn on this exhaust fan, and fan will take away. And now we connected even a heartbeat meter as well as a scanner, where immediately you can see what is your heart rate, pulse beat also. So now we are arranging many. So you can see that we have 6 sensors, and in the top you have a solar plant. From there, this solar plant, this yellow wire, it charges the battery. You can see this black color in the battery here, and they charge this battery. From this battery, you give power supply to us. And you can see that this is the battery controller also here. So the complete unit is very beautifully designed. And this is also, last week, we presented in the Hydrocon, one of the girl from Bhaktiyarpur College of Engineering, Patna. She came here and did her internship, and she published one of the IEEE paper. And based on this technology, you can see here, this is the modified solar tree, that same solar tree, but now we have many sensors are connected, many functions. So first thing, the smart energy management system, okay. We have this smart energy management here. This is the smart energy management. Okay. Then smart healthcare, I told you. The smart healthcare also, we, we discuss about smart healthcare. Smart ventilation actually. So smart ventilation also, we we designed smart ventilator, and then smart people management. These are the four objectives of this smart home. So power is generated from the solar plant. Okay. Power. Okay. Power is generated from the solar plant, and two IoT design protocol are used as a wireless using Bluetooth, short range offline communication, and then Zigbee and Wi-Fi. So if you see here, the entire smart home is done based on solar energy. Security, fire, health care monitoring is addressed here, which is very important in a smart house. And then solar panel through maximum power point tracking, that it will always produce the maximum power. For example, you see the solar production power, it is like the half circle. So in the 12 o'clock in the night, you got maximum voltage, power, and other time you don't get that much power. So how to get maximum power? That is called the maximum power point tracking. Then sensor control scheme. There you have four sensors. So how to coordinate? Which sensor will work first? And this is a big research topic actually. If you go to IIT Kanpur, they are making 100 sensor coordination. Actually, one of the village they put a solar plant. There are hundreds of sensors. Which sensor is first? Like in our house, you was whether egg is first or hen is first. Which is first? So like that, which sensor you will get priority so that it will not affect on the performance of the system. Itself, the sensor coordination is a big topic in the research area in the computer science, electrical engineering, everywhere. That's why whether you will, this sensor control is most important. And this model developed provide online, offline control, monitoring of the smart home, entrance, gate, entrance gate, corridor, living room, and kitchen, respectively, these four. And this is the complete unit, how it is connected. And you can see that from the solar, all the power comes. And at the same time, this passes to MPPT and voltage regulator and comes to this sensors. So if you see that there are different sensors, DHT sensor, this is used for checking the temperature. MQ2 sensor, kitchen, for detecting smoke concentration. Okay. So you are able to see this slide. No. No. So you are able to see my slides?
Yes, sir. Slide is visible. System architecture.
Okay. So then MQ2 sensor, which detect, because why this one I did, I remember we were, our IIT was in Patliputra colony in Patna. That time, we took a room, a rented room for our students to cultivate them, do their morally not sound. For them, we took a room to cultivate them in their academic. So we were teaching them extra. So we took that room. In that house, only two persons were living. One is that gentleman and his wife. And after 4 or 5 days, and his wife came to kitchen and kitchen, the gas was on and whole room was filled with gas. As soon as they put the stick, whole body is burnt and died there. So this is what one of the thing I we had in my mind. So I told my student to put these sensors, and he becomes very happy. And this sensor is very good actually. Even small leakage of gas, this can detect and give you the warning that there is a, or if there is a exhaust fan, it is connected to exhaust, it will go. And that LM is a pulse rate sensor, LM35. When somebody is coming inside your home, whether he has good health or not, you can also understand. Like nowadays, it is very important. If somebody is coming, so you must see this one as a most important thing because nobody has faith that how this corona affect on others. So I remember just in March 12th, March 12th, yes. So I had a flight from Buenos Aires in Argentina to Paris. So everybody has a mask that time, but I don't have mask. So airport authority, that person, that captain told, no, no, you go and purchase a mask, then only you are allowed to come inside. So when I came to Paris, from there to Paris, Paris again I told, no sir, I have kept in my bag. So once I'll get down in Paris, I'll take out. So somehow I was allowed, but in the Paris airport, they did not allow. They told you have to purchase something. So it told, well, you have to purchase and put it actually. And that is what today Corona is very dangerous, that how, to whom it acts, we don't know. So this pulse sensor, it will give you the early warning. If somebody is entering to your home, you can measure this pulse rate also. And there are IR sensors, which will detect the somebody's sensor, or you can put also a CCTV camera also. It can also give you the information. And it depends on how you can process the data. And then the Bluetooth, Zigbee, and load sensors, okay, is used to measure the weight of LPG refill, okay. So that also will give you whether the LPG gas you got, which is gas, it is full
एक टी
or
शर्ट है आरव का टी शर्ट वही सामने ही हम रखे हैं जाकर देखो कहीं मैं आज सुबह ही रखा
so the components are Arduino, Bluetooth, Zigbee, GSM module. Okay, so you can GSM module is used. Okay, others I have already discussed. GSM module is this to make a call, an automatic messaging. Okay, if you want to get, and MPPT is for charging the battery from the solar. That is MPPT. So if you see this is the top view of that one, you have a server room where your battery, MPPT, all kind of controlling device, okay, get edge devices are connected here. And you have a entrance, you have a health scanner, plus the IPR sensor. In the kitchen, gas leakage sensor and lighting sensor. When somebody comes in, it should turn on the light. If there is a leakage of the gas, this fan should be on. Like that, this living room, you must see that when somebody is entered, light should be turned on. At the same time, if it is very hot, this AC should be on, or okay, in that case we put it. And then smart energy management, that if somebody is not there in the kitchen, the light always will be switched off. When somebody is not there in your corridor, the light will be switched off. Like that, we and somebody not there in the living room, then light will switch off. This is what this complete smart energy. And there are sensors, smart sensor networks which connect everything. And then this this is complete. You can see that small health monitoring LM35 sensor. It will give you if there is a pulse rate of abnormal, suddenly it will email to the registered email ID actually we have put, and this will suddenly give, oh, this person who entered into the house, she is not having normal pulse rate, so it will send to email to the head of the house, and as well as you can send to the doctor also for this one. Okay, that way the sensor data and mobile you can transfer, and the health can be monitored and can be taken care. So this is what the result and analysis. You can see that we have developed a mobile app. This app will, you can see, and I can show you here that this light off, okay, as soon as you just click here, this light will be turned on. And similarly, LEDs and fan is off. Temperature you can see it is 25 degrees centigrade. Humidity is 93, and smoke amount to ppm. Then there are Bluetooth connector, heart rate you can see, body temperature you can see. And this app is developed by our own students just to interact with the physical objective, whatever that we design. So you can understand that when you use it and design this one, you will really feel very good that yes, that is one by one step. When you are going designing one step and one step, you will become more and more happy and curiosity that how I can implement this type of thing. Even a small body temperature sensor you connect and you see in your mobile, oh, this is the temperature of the body. So that time you will feel excited. Our students, they are so excited that always that one sensor is working, they will come, sir, it is working. So this is what the practical way that we can design the system. Here you can see that in the web interface, you can understand the humidity, temperature, CO2 also you can calculate. And then you can see these are the experimental result where you can see that heart pulse rate here. You can see from a, somebody enter and there is a heart pulse rate also you can detect through your mobile. And this way, you can send this result to your directly to the doctor, and doctor will communicate with you. Actually. So this way, the when the temperature changes, the temperature is changes. You can see there is a peak little bit. That means that time your when temperature go above the your threshold limit, it turn on the another device. Similarly, there is a room humidity also. You can see that it is perfectly controlled here. Okay. So this is how the smart home, and I can show you this smart home video where you can see that these are the. This is a simple video which you can appreciate that. you can see that you can control from your mobile even. You just click, it will switch off the fan even. So this is what one of the smart home system which we designed in the laboratory. And there are also one of this project is one of the project which you have a big transmission line. You must be seen in your house outside 230-volt transmission line. Generally, transmission lines are connected like this, and how you can control smartly so that without, because this is very high power, and anybody go near between 5 meters, they will burn. So that is a high tension line, how to control those power. And when especially we connect many renewable energy, how this will be controlled. For example, we have a solar farm and a wind farm connected to the grid and two different loads, so the smart meters. So you are seeing here 1, 2, 3, 4 smart meters are there. And according to the status of the load, if the source is having sufficient power, it will supply all the devices. If source is not having sufficient power, it can switch off the irrigation load or the pumping load or this drives load or this house load. So which one he will call? So this way, we designed this complete unit. And you can see here, the complete transmission unit is designed here. And from here, from a solar plant, we set the power. And this solar power, and it moves from this side to this side. So this is a solar plant. From here to it move to the load through this transmission. It moves from here, this road, and this load, and these are the transmission line. It comes to this. This is a model actually. So this model, you can see there are many these are the sensors. You can see these are the smart sensors and which are connected in each interval. And this is the load, and this is a big line transmission, and everything is modeled here. And now you can see here, by using mobile, you can understand that you can operate big breakers. So whether you want to feed the power to the home or to the industrial load or to the irrigation load, just by clicking here, welcome home. Here, by just clicking here, you can turn on the device. Actually. When you click here, it will turn on the smart breaker 1. Okay. If you click here, it will turn off the battery breaker 3. If you click here, it turn off the breaker 3. So similarly, these are the smart meter where you can monitor from your mobile. You can see what is this wattage, ampere, and the voltage. And when the load is changed, you can see what is this ampere. These are this power. You can see that as the current increase, your wattage also increase. And that you can see. You can design. This app was designed by our own students, and they could able to do this one. And you can get the smart energy meter, and you can see that this is one of the best imprint project which selected in IIT Delhi, the IoT based the microgrid system. Also got another award, is the Power Grid Tech Award this year for this project. Okay. So this is mainly, if you see here, a small video where my student is explaining how this is working. So yeah. So anyway, this is my student is explaining that we have these smart switches, and you see here voltage is 230 volt. Okay, and here you are saying 235 volt. That means your sending, if we have a 230 volt, receiving end voltage is higher than the sending end voltage. So how to monitor that one? So when you turn on the load, then automatically voltage equalization. And you can see this one just by a mobile app they have developed. From that app, you can easily monitor this power. Actually, you can turn on, turn off, and completely control. You can do this one. Okay, so you can see that the current is now flowing as this. It has also self-healing capability. If there is some fault, it will detect and inform you. At the same time, if it is capable, it will isolate the system and tell you this information to you. So like that, we designed another smart electric bicycle. And you can see here, if there is an obstacle, it will give you some buzzer sound that somebody is coming. And even if it will tell you if this what is how much battery state of the charge remain, whether the cycle will go how many kilometers, this also will show you that after 5 kilometers, your charger will be your battery charging or battery will be off. And this cycle, one of our students he designed, you can see this is kind of hybrid cycle. Even if power is not there in the battery, you can pedal. And this is a special design we did. And this complete unit is very smartly you can you can see all smartness of this smart cycling. And there are also few cart we design, which is for example, we have some smart vehicles we design. And this is another, there are two wind turbines. You can see it is here in our IIT Patna. So there are two wind turbines. One is here, is a horizontal axis. Another one is a vertical axis. And this two wind turbine is connected through the solar tree. Here is the solar tree. And from solar tree, it is through IoT device is connected to charger controller, battery, and connected to the street light. Okay. And this smart grid, you can see here, here is the wind, solar, controller, and smart load. And complete unit is designed in this IIT Patna, and this is demonstrated here. Okay. Thank you very much. If you ever have any questions or comment, I will take up.
Thank you, sir. With this, we have come to the end of today's session on IoT and smart devices. Is there any query from the attendees? You are welcome to ask if any question from your side.
Even you can give in chat box also.
Yes, you can write your query in the chat box also, or you can unmute your mic and can ask the query. So no query. Thank you, sir, for such an interesting and informative session. Thank you for gracing us with your valuable presence and sharing with us your findings and opinions today. You have given light on the most important terms of IoT, like gateway, edge devices, internet storage, cloud, analytics, visualization, etc. Sir, you have very well explained the story of IoT and how it has become an important part of today's life. You have also highlighted many IoT-based projects running currently, and the videos and the application part was very interesting. I hope everyone attended this program has got the insights of the topic. I once again thank you to the speaker for sharing his expertise. And now for the attendees, we will be making a Google Classroom today and we'll be sharing the link with you and all the study materials, PPTs and the recordings we will be sharing on that Google Classroom. And all the sessions are mandatory to attend, at least 80% attendance. And on the last day, we will have one online quiz and 60% marks in that quiz is required for the certificate from AICT. And please don't forget to put your feedback on the AICT portal on the last day of the session. So thank you all. Thank you once again.
Thank you so much, everyone, and as well as Bhavna Madam.
So I would request all the participants to please put your video camera on so that we can take one screenshot. Thank you. Tomorrow we will start the session at 10 o'clock. Till then, goodbye and have a nice day. Thank you all.